Hello, welcome to Geometric Virtual Learning. If you are new to this site, you are welcome also. And in this lesson, we'll be talking about Pythagoras Theorem in 3D. This is lesson 2 on Pythagoras. If you haven't watched the first one, I recommend you watch that one before this one. So in this lesson, I'll be taking you through the application of Pythagoras in 3D and how to use it to solve reasoning and problem-solving questions. Okay, here we are supposed to find the longest diagonal of this cuboid and give our answer as one decimal place. First is, what is the longest diagonal of a cuboid? There are more than one longest diagonal and they are all of equal length. So I'm going to go through that before I explain to you how to work out the length. So the first one is line AG. From this point to that point, BH is also longest diagonal, EC longest diagonal, and FT. So there are 4 of them and they are all of equal length. So in an exam, if we are asked to work out any of these lines, the method is the same. So now let's look at it. To work out the longest diagonal, let's say AG as a reference point. You know, AG doesn't necessarily make right angle triangle. So to work out AG, we need to work out line AC because ACG make right angle triangle. And so we need to work out line AC. And to work out AC, we can use 3 and 8 to work out AC. So using the calculator method, AC will represent the square root of a squared plus 3 squared. That will give us a number for AC. And now if you want to work out the longest diagonal, which is AG, we need to use this value M5 to work out AG. So we end up using 8, 3, and 5 because this one is combination of 8 and 3, and 8 and 3 we're going to use it with a 5, so we end up using all the sides. So in short, what this means is that when you want to work out the longest diagonal, it's simply the square root of squares of all the 3 sides. In general, this is the formula. Longest diagonal is always the square root of the length squared plus the width squared plus the height squared. That's when you are looking for the longest diagonal. So here our answer is 9.9 cm. So remember this. Longest diagonal is always the addition rule. Square root of all the squares of all the 3 sides. Length, width, and the height. 3 dimensions, sorry. Now, what if we've been given the longest diagonal, but a side of the cuboid is missing? Right. Now remember that the longest diagonal is 25 squared, this side squared, is equal to 21 squared plus 10 squared plus y squared. Then we work out the square root of that. That's what we did before. If you look at this is everything squared, then work out the square root to work out the longest diagonal. So if the longest diagonal is given, see the relationship like this. Now make y the subject because that's what we are looking for. Work out these values, and at the end work out the square root on both sides. So in general, if it is not the longest diagonal that you're looking for, this is how you should quote your formula. It should be square root of first the longest diagonal minus the square of one side minus the square of the other side in order to find the third side. So it's y is equal to 9.2 cm. Right, pause it and read this question to understand before we continue. Joseph wrapped a parcel in a shape of cylinder below. For decoration purpose, he attached a ribbon from point F on the top to S directly on at the bottom, going around the cylindrical parcel. So the ribbon is going round. Point F is directly on top of point S. Okay. The height of the parcel is 15 cm. Okay. Diameter of the parcel is 10 cm. Find the length of the ribbon. Now, these kind of questions, every time that you read, check. If the information is not there, you put it there, like 15 cm. If it is not there, you label it. Diameter, if it is not there, you label it. Now, this question is easy if you try to understand it, that this is 3D, but it could also be changed into a 2D Pythagoras. Now, look. Imagine that we split the cylinder open at point Fs, and you roll it, you open it up. The ribbon will look like this. If you like, take a rectangular paper and draw a diagonal and fold it into a cylinder. You see that the diagonal line will go round the cylinder and it will look exactly like this. So now, knowing that the ribbon is actually a diagonal of a rectangle, it's a simple matter of working out the Pythagoras theorem here. The height here is 15, so this side is 15. But remember, this is a circle. So when you split it open, that is the circumference. So we need to work out the circumference. Knowing the circumference and the 15, we can now use Pythagoras. So we have this. Circumference is pi times the diameter of the base of the cylinder, and that is 10 pi. So we have 10 pi and 15. Longest side is the addition rule. So the ribbon is square root of 15 squared plus 10 pi squared, and that will give us 34.8 centimeter. 34.8 centimeter. So that's one application of Pythagoras in 3D. Let's look for final problem solving question. We have a pyramid, and it says the slant height is 8√3. The height of the pyramid is x, and the base sides are 2x into x. This is non-calculator question. We're supposed to find x. So we're going to use relationship between Pythagoras to generate equation and solve. So the first thing we need to do is this. Let's focus on right angle triangle BCD. So you know that because the base is a square, that makes it a right angle triangle. So we can work out BD using Pythagoras relationship. BD is the hypotenuse. So BD squared should be equal to 2x squared plus 2x squared. Okay, so we are using Pythagoras to work out BD. So this is what we have. Now be careful. 2x squared is 2x times 2x. So the answer, be careful, is not 2x squared. The answer is 4x squared. So we have 4x squared plus 4x squared. 4x squared plus 4x squared, that will give us 8x squared. So BD squared is equal to 8x squared. If you want to work out BD, you work out the square root on both sides. And square root of root 8x squared. This brings back the knowledge of sets. If you've done set, you would understand what I'm talking about. 8 is the same as 4 times 2. And you can work out the square root of 4, that will be 8. But you cannot work out the square root of 2. So square root of 8 is 2 root 2. Square root of x squared is x. So when you work out the square root of 8x squared, you're going to have 2x root 2. So you might need to review your set principle. So BD is 2x root 2. So that one is done. Next, given this as 2x root 2, we can work out what is BO and use BOA as another right angle triangle and see relationship with x, BO, and 8 root 3 to work out x. So then we're going to focus on BOA. That's also right angle triangle. Using Pythagoras, we can see that AB, which is the longest diagonal, is equal to AB squared is equal to BO squared plus OA squared. But you know that BO is half, because this is the center, half of BD. So 2x root 2 divided by 2 gives you x root 2. So we now know this x root 2. So we replace BO squared with x root 2 squared. So we're going to have AB, which is 8 root 3. BO x root 2 x is x. So you're going to square 8 root 3 squared equals to x root 2 squared plus x squared. Work each out. Now be careful. 8 root 3 squared is 8 times root 3 times 8 times root 3. So it's best to rewrite everything in the long form. And 8 times 8 is 64. Root 3 times root 3 is 3. 64 times 3 will give you the answer as 192. The same way, root 2 times root 2 is 2. X squared is x squared. So that's what we have this. So now, given this, when you add this up, 2x squared plus x squared, the same as 2x squared plus 1x squared. That will give you 192 over x squared. Solve x squared by dividing both sides by 3. That will give you 64 is equal to x squared. We are looking for x and not x squared. So find the square root on both sides. X is equal to 8. X is equal to 8. And that brings us to the end of lesson 2 on Pythagoras. Application of Pythagoras in 2D. Look forward to my next lesson on trigonometry. Basic trigonometry. Then we're going to go on to advanced trigonometry. If you've enjoyed this lesson, share with your friends. Subscribe. Hit the notification button to be alerted of my new videos. Thanks for watching. Thank you.